So a couple of observations to make on the differences between LPRPG. Well, the first one is that there is actually no upper bound on the number of times an action can be applied. So if it appears in the RPG, we can apply it infinitely many times. Now that's very different to FF. FF says if we've got 4 of material and we use produce, we've now got 3 of material. And we can only apply produce once at each layer. That's a restriction it makes. What we say is actually if you can apply produce, you can apply it as many times as you like. Look, we've got no constraint here saying an upper bound on the value of P. So we can apply produce as many times as we like. What actually restricts the number of times we apply produce is the actions here. So because m prime is m0 minus p, and we know m prime has to be greater than or equal to 0, I've actually missed it off here, then we can see that we can only apply p a maximum of 4 times. So that is what restricts us in the LP from how many times we can apply it. It's actually the values on the preconditions rather than the values, rather than just saying we can apply it once, like metric FF does. So actually in practice, to stop the LP going to infinity, so say produce had no preconditions, we assumed infinite material, then we obviously we might want to apply produce infinitely many times. So in practice we just put a constraint on the LP that the action variable is less than 100, just to keep things sensible. So observation 2 is that the LPs for successive layers are very similar. So there's not a great deal of difference between the LP for layer 1 and the LP for layer 2. You can see them here. They're quite similar. The only difference is that newly applicable actions are added to the LP at the next layer. So if we have the LP here, this LP has an extra action. You can unload at the store or unload at the site that this action doesn't have, and these then appear here in the various constraints on the variables. So that's quite nice. When you're constructing an LP for subsequent layers, you know it's quite similar to the previous one. There's no great need to change it. And indeed, what we actually can do is we can use some bounds from the previous LP and initialize the new LP with those. I'm not going to go into that, but that's an efficiency thing. We can take something from solving the previous very similar LP to solving the next LP. So this is just to make more formal how we construct an LP at each layer. So in the general case, for a given planning problem, we construct variables v0 to vn for the initial state. And these are just the values of the variables in the initial state. So in our example, we have the amount of packages in the lorry is 0, the material at the site is 4, and so on. And then for each variable, we also create another LP variable, which is the value of that variable at the layer we're talking about. So if we're at layer 2, it will be layer 2. If we're at layer 3, it will be layer 3, and so on. And this is the value of the variable at the end of planning. So effectively, it's the value of the variable at the layer we're looking at now, after we've applied all the actions we're going to choose. We have action layer variables. So for all actions that appear before the current fact layer, so if it doesn't appear in the RPG, we don't put it in the LP. It's not appeared yet in the RPG. So A1 to AM for every action that appears before the current fact layer, telling us the number of times the action's been applied. Now, strictly, these should be integer variables. We can either apply loading a package onto a truck, or we can't. we can't load 0.6 of a package onto a truck. However, this is a relaxation. We want an LP, not a mixed integer linear program, because they're more expensive to solve. So we're just relaxing this constraint. So here the LP can choose to apply one action 0.5 times if it wants to. We will see later how that we can get around this, because it gives us a problem with helpful actions. If it tells us to apply 0.1 of an action, is that a helpful action or not? It's quite tricky. So I'll come back to that later, how we can deal with that. So that's the variables for our LP. We have action variables, values of fluence at the start, values of fluence at the current layer. The constraints in our LP. So constraints between the initial value of a variable and the value of that variable at our layer are the value at our layer is its initial value plus this function here. And all this function here says is plus the sum of the producers minus the sum of the consumers. So all actions that increase it, we add that to its value. All actions that consume it, we decrease it for that value. Note it's a weighted sum. So if an action uses 2 units of a certain resource, then obviously we take off 2 times the number of times we've applied that action, and so on. So, back onto our LPs. Now we've seen formally how we can construct them. These are our values in the initial state. Sorry, these white ones here. These are our final values, and these are our action variables for each action that's appeared so far. So the only actions that have appeared are produce and load at the store. So we've got those here. You notice there's nothing we can do to the site at this layer. There's no way we can unload anything at the site yet. We've not got there. So we just get this quite boring constraint that the site at layer 2 is a site at layer 1. Well, layer 1 is the site at layer 0. Because there are no actions we can do to change that. And then when we get a bit further, we can add in the unload at store, unload at site actions, and these then become here in the LP, because they can increase the number of things here and decrease the number of things here. So that's essentially how we build an LP for each fact layer of the planning graph. So the only remaining question really is, how on earth do we make use of this LP?